All right, we're back. I hope you enjoyed the quick break. We're going to move straight into a talk by Comcast on hybrid analytics. I'll turn it over to Bryan to get started.
Welcome. Thank you for your time in advance. So my name is Bryan Aller. I'm a Director for Engineering at Comcast, and with me I have Pavan Madnani, who's a Principal Engineer on my team. We're responsible for Comcast's Starburst platform implementation. Today's topic, we're going to talk about hybrid analytics, specifically going from ground to cloud and cloud to cloud. As far as today's agenda goes, our first section is talking about why hybrid analytics is so important, a little bit about use cases, the overview, the problem space, and the challenges. Next, we'll talk about our vision to reality, what that evolution looked like, ultimately the technical solution and how it came together. And then finally, we'll do a recap of our reality and practice, talking about our journey, the performance gains that we now have, as well as this universal solution. So hybrid analytics, this space has changed a lot, over the last few years. Analytics is a common term, for some folks. Hybrid analytics may be a little bit new. Ultimately, looking at the hybrid analytics space, we have, a variety of different use cases. Some of our use cases that were on-premise are part of the traditional pre-cloud approach. We have back office systems, things that are highly sensitive, and they're stored either in bare metal or virtualized hosting in our own data centers. Some of these solutions may never move to the cloud. There's also a lot of discussion around cloud migration and putting solutions into the cloud. In fact, some organizations have so much in the cloud that they're now working on multi-cloud use cases where, due to high global availability or reduced physical infrastructure costs, or maybe there's a cloud-based partner that we're trying to coordinate with, we find ourselves, supporting cloud-only use cases. As time goes on, there's going to be use cases, and there are many use cases now where we need to be able to join between both on-premise and the cloud, enabling hybridity, bridging that gap. How do we integrate the old systems, with the new? This becomes even more important, when you look beyond your old and new systems and you start looking at all of the different types of data that we have. When you work in, a diverse, big data ecosystem, you may have data ranging anywhere from traditional relational databases to data warehouses, to the big data lakes, like Hadoop and S3. There may even be unstructured data or, atypical, data from, the traditional relational model. Might have graph-based data or document stores. Maybe you have flat files. And increasingly, more and more these days, we're seeing cases where we need to be able to do ad hoc analytics across all of these stores and integrate streaming data. This leads to a pretty new problem space. Traditionally, data integration was something that happened on one local platform. Maybe there was an ETL job or duplication of data, or maybe there only was one data warehouse and all of the data could be stored there. As time has gone on and more organizations have gotten into the big data space, what we found is that their needs varied. And it was easier for them, to differentiate and find tools that better fit their needs. Ultimately, this led to some differentiation in tooling. This divergent thinking of thinking, oh, well, we can solve one problem a little bit differently, with a different tool in a better way for my organization. Look at examples like, Linux distributions. They've diverged many times. In fact, the family tree for Linux is probably larger than could fit on this slide in a readable format. So looking back, this is over the last decade or so, there have been a lot of changes. How did we get here? Differentiation is definitely easier than integration. It's easier for me to find a new way and fork a code base or a tool and build something new than it is for me to try to find one solution that's one size fits all. However, there are benefits to that. And if we look to nature, there's this concept of convergence. Take, for example, a trait for swimming. Let's say that water covers 75% of the earth, and animals need to be able to adapt. Well, there are a variety of different families of animals, whether that's reptiles or mammals or fish, that have all evolved different methods of being able to swim and take advantage of this ecosystem. And so that swimming trait is an example of convergence. Multiple different previously divergent solutions that have actually come together and evolved in a way that makes sense, for the use case. So let's imagine for a second here that we were to do, this same type of convergence, but in the data integration space, that we wanted to do ad hoc analytics in a way that made sense and took a common approach, using SQL, for example, which is often the language of choice. What would that solution look like? Ultimately, I took that argument back to my leadership. And back in 2016, when I emailed our VP of Big Data Engineering, I suggested that we needed a more general strategy, for standard query abstraction. One of his first questions was to talk about, what some of those challenges may be and how are we going to address them. Ultimately, heterogeneity, this varied approach of multiple clouds and multiple tools and multiple data centers, how do we bring them all together? How do we get them all to speak the same language? Those challenges, vary a lot, and they actually, cross these platforms from end to end. So for example, identity management. How do you keep track of the same user across multiple systems? When some systems keep track of, their user as a local database user, and others support single sign-on. How do you govern your data and keep track of where it is? You might have multiple metadata schemas, multiple relational stores. Managing access to the data access policies. Each system might have their own security model. How do you bring them together? Network firewalls, maybe they live in different zones. The cloud, versus a local data center are two very different animals. Per our earlier slide, different storage mediums, different formats. Ultimately, those formats could be living on different systems, which when we bring them together might, lead to performance concerns. And then ultimately, keeping in mind, all of these different varied experiences, these varied tools, these varied performance expectations. How do you stitch together a seamless cross-platform experience? The good news is we actually have solved for these. We have a production solution today where we've taken that vision and we've made it a reality. So our next section here, we're going to talk a little bit about how we made that happen. Sticking true, with the nature theme, looking back at evolution in nature, what would a hybrid solution look like if we were to use nature as a metaphor? Let's say that our ideal solution, was baked down to 4 parts of DNA. One part was solution parity with our on-premise solution. Another part would be solution parity for the cloud. The third part would be a bridge between the two, bringing them together into one solution. And the fourth part, this is the future-proofing part, the forward-looking part, is the evolutionary potential, the ability to freely extend these solutions to support future use cases. And with that, looking at these genetic components, I'm now going to turn over the presentation to Pavan, who will talk a little bit about how we actually made this happen.
Thank you, Bryan. Hi, everyone. For the next few minutes, I'll be covering the details on the journey that our team at Comcast has taken to make this vision of hybrid platform into a reality. We'll go over the details on why we had to do it, how did we do it, and what did we accomplish in that process. Back in 2006, Comcast has started moving into the big data space and started storing large quantity of massive event level data in Hadoop. Comcast by then also had this big data warehouse system called National Data Warehouse, which was hosted in Teradata. The challenge to many of the data analysts, data enthusiasts, or even the engineers was that the events were getting stored in Hadoop and all the semantic information and the business rules were being stored in Teradata. So any kind of analysis, any kind of troubleshooting solutions would require the need to join these two data sets. And the only option at that point was to build a massive ETL process to move data from one platform into another. Also, to do an in-place analysis, users would need to know different languages or different ways to query that needed data. This challenge was thrown to us, and that's when we started to build our on-prem query engine, back then Presto, which is now Trino, instance with which we solved the problem and provided the ability to our end users to read the data from different data sources, which improved the user experience and it made it easy for them to query from both the Teradata and Hadoop platforms. And this avoided the data duplication process because there is no longer need of this massive ETLs, and the storage cost has reduced because there is no movement of data from one source to another. So after that, in 2017 and 2018, people started noticing this. And in Comcast, being such a big company, various teams were not just storing the data in Hadoop or Teradata, but they had their own data sources, their own relational data sources, be it an Oracle, SQL Server, and all this. So we had to expand our on-prem query engine to provide the ability to connect to other data sources. And with that, the adaptability of the platform has increased. And so it is, with this such a cool technology, it made a lot easier for users to use. Users didn't have to learn anything new and don't have to worry about copying the data. All they needed to do was bring their SQL knowledge to the table, and the rest, the platform did the magic for them. In 2018, Comcast has announced that they're signing an agreement with AWS to be the preferred vendor for providing the cloud platform solutions to Comcast. With this, we had to adapt to this, and we internally came up with a solution to deploy our cloud query engine in EC2 instance. In there, we did the same, integrated the same security mechanisms as we did in our on-premise instance, and we use the same custom logging. And we also, with this implementation in AWS EC2, we were able to enable the auto scaling feature, with which we could scale the nodes that would require for the query processing up and down based on the capacity. And at the end of the day, the user experience was seamless. Users who made, I mean, like the querying of the data from S3 buckets was made simple for them, or anything that is stored in cloud, it was made simple for them. They didn't have to worry about how to work with the new cloud technology. All they needed to do was, again, come with this the SQL steps. So that's how we got into the cloud query engine. So we now have two query engines, one on-prem and one on cloud. With that, the challenges definitely grows. As we are growing, the challenges also grows. People started adapting the platform, but they were looking for a capability and a need to have a federated access where the users can join the data between the on-prem and cloud data sources. To enable that access, we did encounter multiple challenges, be it network challenges, as Bryan was mentioning, and we had to upgrade the clusters constantly between on-prem and cloud and between these two environments. So, and we need to ensure that the process, when we are combining or when we are providing the ability for the users to join these two data sets, it is secure. The data needed to be secure both in transit as well as at rest. So users were in need of making this accessibility of the data set should be made easy. In other words, we were asked to build this hybrid platform that would access both the data sets, and there was a need for the stitching of this data, which is when we came up with our solution of Query Fabric. The Query Fabric solution enables the stitching functions which the users were looking for. The brain behind this Query Fabric is our Trino to Trino solution. This is a solution where an instance in on-prem would talk to an instance in cloud, and vice versa. An instance in cloud would talk to an instance in on-prem, essentially establishing this Trino to Trino connector. This is based on JDBC, and this solution, whenever an user logs into any of these, either an on-prem or a cloud instance, all they would see is all the catalogs that are available for them, be it on-prem or be it on cloud. So users can come in from any instance, but the various catalogs that would be available on both the instances, it would be shown up from there. And user doesn't have to know where exactly the data resides. The security and the accessing of the data is all maintained, and all the data sets in both the instances is provided irrespective of where that resides. This solution, I mean, like the Trino to Trino solution, the more details you can obtain from another session where my colleagues Saj and David are going in detail, in depth of the architecture that we have used. What are the things that we have built in this solution? So to give you a high level here of how this solutions works, when a user logs into an instance in on-prem or on cloud and submits a query, the authentication of that user happens on that instance wherever the user has logged in. And the cluster wherever the user is logging in passes on the user identity and the client certificates to the other instance. And we don't maintain any user credentials. We just carry the user identity from one instance to the other instance. And the user, which is accessing the data of the other instance, will check the identity against the ranger, and then the other instance where the data is stored, the query runs it, and then results are sent back. That is the high level gist of the query fabric solution that we have. And as the adoption grew, the number of users started using it. They saw the flexibility. They saw the power of this platform, and this then started asking, "Hey, is there a way that we can connect to other data sources like Delta Lake, Snowflake, Kinesis, Elastic?" And that's when we started partnering with Starburst. Starburst have these enterprise level connectors where different data sources can be connected using the connectors that are available. So we enhanced our query fabric solutions to include the Starburst implementation in there. And as the platform started growing, there was need of enterprise level support as well. So which is what the Starburst is providing us with, that enterprise level support of these various connectors, various instances. And in that process, they gave us this enhanced Teradata connector, which is helping our Teradata users, which is making their lives more simple and querying the data from Teradata, because they don't have to run the Teradata SQLs. They just have to come into Query Fabric, use their SQL knowledge, and get the data back. Currently, with this platform, we are pulling about 250 to 300 terabytes of data in a day. And we have both the implementations of Starburst and Trino and this Query Fabric platform. And this platform is working together and providing the hybrid solution and providing the different data access to all our end users at Comcast. With that, I'll pass it on to Bryan.
All right. Thank you, Pavan. So in retrospect, we've had quite a journey here. Architecturally, we've evolved quite a bit. There's been a lot that's happened over the last few years. I want to go back to a demo that we did internally of this solution to our broader organization. And it could be very nicely summed up, also in Pavan's own words, as query federation has been made simple. So let's look back. Now that we've been in production for a while and onboarded hundreds of users and thousands of data sets, what does the reality of this solution in practice actually look like? Taking a step back to look at the big picture, identity is now managed in a singular fashion. Data access policies are uniformly managed for most systems. This is networked to look and feel like a seamless solution. Ultimately, the many storage mediums and formats that we pictured earlier are no longer a serious issue. These have been abstracted and are now all available through standard SQL. Cross-platform performance is efficient. We're no longer duplicating data. We're letting the data live, in the source systems themselves. And this cross-platform experience has gone from something that was previously not considered, where everyone was happy to run their own silo, to now expected. And when it doesn't work this way, there's a lot to say. But most days, this experience is now something that people don't think twice about. In addition, there have been a number of significant performance gains. This doesn't just work, it's also fast. To name them all on this slide would probably be more than we could possibly fit in text. So just some major highlights. The Hadoop jobs, specifically those that run on Hive natively, are running approximately 10 to 20 times faster through this solution. We have a number of cross-platform jobs that used to take hours that run in minutes, and some that used to run in minutes, happening in seconds. And for those of you who may be doubters here, these aren't small queries. We're talking millions of rows. And since folks don't have to do ETL development, we're not waiting as long, for data to be available in these environments. Engineers and analysts can explore it in real time. Even better is the fact that they don't need to learn all of the platform-specific languages. Long past are the days of learning specific Teradata SQL or Hive SQL or, Oracle PL SQL. There may still be a need to know that on a platform-specific basis, but the general user, has a faster ramp-up speed because they only have to know simple ANSI SQL. To the extent that we even have folks that are non-technical in nature, including management and even senior leaders, who are now able to access data in our data lake. This has really turned out to be a universal solution. So going back to the very beginning of our presentation, when we talked about what it was like to have solutions on the ground, the on-premise solutions, and the cloud-to-cloud solutions, and ultimately looking for a solution of ground to cloud in between, we now have a universal solution that spans all of these spaces, specifically driven by Starburst data, open source contributions in Trino, and a Comcast provided Trino to Trino connector that bridges both the on-premise and cloud Starburst and Trino clusters. We actually have a presentation tomorrow in which Saj and David from our team will talk about that Trino to Trino connector in full technical detail. So looking back at this universal solution, we now have one technology architecture that works for the solutions that may never move to the cloud, for those that need to be in the cloud for elastic scaling. And we have the capability to support hybridity of both old and new use cases. Even better, we have a clear path for cloud migration as more and more use cases do move in that direction. This is quite a feat of engineering. But our journey's not done yet. Future-proofing is always a consideration, especially in an organization and in a technology field such as this one, where big data is constantly changing and the tools and technologies are evolving almost daily. So if hybrid analytics ties together both the ground and the cloud, what comes next? In the cliche sense, some folks say look to the stars. So what does that mean? And I'd like to say that with open source Trino and Starburst data, we have this pluggability and extensibility. And if we look to the image on the right, there's a bit of inspiration of what it would look like to look to the stars. If we've taken our data centers, from the ground to the cloud, and we're now looking beyond Earth, there's an analogy and an image here from NASA that may be a good fit. So in 2018, NASA launched the Regolith Explorer spacecraft to travel to a near-Earth asteroid. The intent was to bring a sample back to Earth for study. That spacecraft landed, and it collected the data and collected the samples. And in all senses of the word, that data has been collected and is now on its way back to Earth. And in 2023, when it reaches our planet, we'll have now, seen data on Earth, in the cloud, and in the stars. What does that mean for Starburst and Presto? I don't know just yet. We'll look forward to seeing that soon. We appreciate your time. Thank you very much, and we'll look forward to any questions during our subsequent panel.
Thank you so much to Team Comcast for a great overview. And if you'd like to learn more about Comcast's use of open source Trino in their query fabric, check out the technical track session on their Trino to Trino connector. We'll get started in a few minutes on our next talk. Take a quick break.